Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. I hope everybody is doing fine and in good health. To begin with, I would like to emphasize that site investigation, or SI, is an important step or process that must be performed before the commencement of any civil engineering project. Considering site investigation is a broad topic, I decided to divide my talk into 4 different segments of 4 different videos. In this first video, I will talk about the definition of site investigation, the objectives of site investigation, and site investigation program. In order to explain what site investigation is, let's refer to this slide. Site investigation is a combination of activities which include data collection, followed by data evaluation, then reporting the collected data and the outcome of the data evaluation. So these processes or these steps are performed in order to obtain safe and economical design. Geotechnically is to obtain safe and economical foundation design. In order to achieve the aims, which is to obtain safe and economical design, there are 3 objectives that must be satisfied. First, to assess the suitability of the site. So the suitability could be in terms of the location of the proposed site, or maybe depend upon the availability of infrastructure within the proposed project site. So based on those information, so we'll be able to assess whether the site is suitable to be developed with the proposed project development. Number 2 is to plan the method of construction. Depending upon the type of a project development, there are several construction methods that can be chosen from. Again, depending upon the project development or depending upon the proposed project, so we'll be able to select the appropriate construction method. The appropriate construction method must be selected in order to make sure the project will be completed within the time frame as well as within the allocated budget. Number 3 is to determine the changes that may arise in the ground and environmental condition. The changes in this case could be, the changes or the impact could be in terms of positive impact as well as negative impact. So this impact could arise during the construction, after the construction, or during the operational phase. So the positive impact, for example, by having this project development, it may provide job opportunities to the locals. Or with the completion of the project, maybe it will beautify the surrounding area, or maybe will improve the infrastructure of the surrounding area. Those are among the positive impacts due to the proposed project. For the negative impacts, it could be in terms of pollution to the groundwater, pollution to the air, pollution to the ground, or maybe due to the emergence of a disease vector. So those are the 3 objectives that must be satisfied in order to achieve the safe and economical design. Okay, let's move on to site investigation program. So I plan to explain 5 steps in order to perform this site investigation program. So the first step is gathering of available information of the proposed site. So when we talk about the proposed site, there are several sources that we can obtain the information, such as maps. There are several types of maps that we can obtain information. For example, geological map. So based on the geological map, we'll be able to to know the geological condition of the proposed site, whether that area is a granitic area or due to the maybe covered by sediment and so forth. In addition to that, there's another type of maps which is topographical map. Based on this topographical map, so we'll be able to observe whether the proposed area is a flat area, an undulating area with hills and valley. We know the highest point or the lowest point with respect to the mean sea level. So those information can be obtained from topographical map. Another map that we can refer to is land use map. This land use map normally is provided by local authorities. Okay, so normally these local authorities will prepare the land use map where they divide their jurisdiction into several zones, such as certain zone for industrial, certain zone for residential, certain area for commercial. Another source that we can obtain information for the proposed site is aerial photos. Nowadays, with the availability of Google Photos, so Google Maps, or Google Earth, so we can observe the proposed project area based on these aerial photos. Based on these photos, we'll be able to observe whether this area is covered by trees or covered by buildings and so forth. Hydrological data, where we can obtain from the meteorological department, or maybe we can obtain this hydrological data from nearby airport. So based on this hydrological data, we may be able to identify when the rainy season is, when the dry season is, the strength and the direction of wind. So for example, if we are to develop high-rise building, it is important for us to know the strength or the direction of the wind, because those factors must be taken into account in the design. In addition to that, we may refer to SR report for the nearby existing structures. If there are nearby existing structures, they must be SI report, because before they develop the structure, they have to perform SI, as what we are discussing now. Okay. So if the buildings belong to government agencies, normally we can obtain the SI report at minimum cost, or maybe no cost at all. But normally, if those buildings or those structures belong to private sectors, normally it's quite difficult to obtain the SI reports. Okay, never mind, but those are among the sources that we can obtain information about the proposed site. Step number 2, after gathering the available information of the proposed site, is the gathering of information of structure to be constructed. So it depends on the type and function of the structure to be developed. It could be school, it could be multi-story hotel, it could be a shopping mall with offices and so forth. So by knowing the type of structure to be constructed, we may be able to estimate the column loads, for example, and then maybe we have to identify what local building codes to be used in the design. So these two steps, gathering of available information of the proposed site, as well as gathering of information of structure to be constructed, some people refer to as desk study. In this case, normally we just sit in the office and then we just gather all the information. That's why we call it as a desk study. So this is an example of a geological map of Peninsular Malaysia. So by looking at the colors here, it represents a different type of rocks or different type of sediment. Okay, this is an example of topographical map where we can see all the contour lines, okay, to represent similar elevation with respect to the mean sea level. If you can see the blue or yellow lines here, it represents rivers. Okay, so this is an example of a topographical map. So by referring to this type of map, we may be able to identify whether this area is a flat area or undulating area and so forth. Okay, this map is what we call land use map. So within this area, the local authority has what we call gazetted certain zone for certain purposes. For example, for residential area, as I mentioned previously, certain zone may be gazetted for commercial area and so forth. Right, the next step of the in the site investigation program is site visit, meaning we have to go to the proposed site. So it is important that we visit the site so that we can get first-hand or primary information of the actual condition of the proposed site. So if we visit the site, so by looking at the vegetation, maybe we'll be able to get clues in terms of the type of soil and condition, whether it's a sandy area with a watery area or dry area and so forth. If open cuts are available within that area, we'll be able to see the soil strata for the proposed project area. In addition to that, if there are nearby structure and if you observe cracks on the structure, it may indicate the presence of soft or expansive soil. So let's take a look at this picture. It's a nice picture here. So by visiting the site, that we know that this area is provided with this access road, and then with this power supply, this drainage facility. Actually, it's a paddy field with the background here is a mountainous background. It's a nice area. Okay? And by visiting this site also, we may be able to identify maybe the area is a bird sanctuary and so forth. It's just an example. Okay, okay, this is let's say this is the example of a project site within a busy area here. So by visiting the site, so you will have idea how to go about it with this busy area, how to control the traffic, how to bring in your machines into the project area. Okay? If you don't visit the site, you may not have the idea how to go about this problem. Okay? That's why it's important to visit the site. So if there are open cuts, for example, such as in these photos here, we can see the layering of soil. Similarly with this photo at the bottom here, so we can see the layering of soil. So by observing the open cuts, we will have idea what type of soil covers the proposed project site. So let's say this is the existing structure nearby our project area. So we can see the crack here. It could be due to the settlement, or the settlement of the structure, or settlement on part of the structure here. Okay. Again, we visit the site, so we have idea. For example, in these photos, we can see rivers. So when we see the river here, so we have idea how to go about it. Are we going to cross a bridge to go to the other side of the river, or maybe we have to look for other route to go to the proposed project area, for example. Okay, here's an example of, let's say this is the proposed project area. So we have here palm, it's oil palm here, with the existing drainage with the earth drain. And then if you visit the site, if you have the opportunity, say, you can check the pH of the water, whether it's acidic or alkaline. Okay. This is an example where you can see cracks on the ground surface. So if you see this type of cracks, it indicates the presence of soil that prone to swell and shrink. So when it's in contact with water, it will swell, and when it dries, it shrinks like this. Okay, so it indicates that the presence of maybe clay soil here. So if you go and visit the site, maybe you'll be able to perform certain tests. Let's say for the guy in this photo is performing vein shear test. So this vein shear test will give us the strength of the soil. The next step is preliminary subsurface exploration. So the purpose of performing this preliminary subsurface exploration is to obtain general information below the ground surface. I would like to stress here is to obtain general information, not the detailed information. There are several methods that we can employ to perform these preliminary subsurface explorations. For example, here, geophysical exploration. There are two methods that I want to explain or want to touch in this case. One is resistivity survey. So resistivity survey is based on current being applied to the soil, where the resistivity of the soil will be recorded. Based on the resistivity, the soil type can be identified. Another example of a geophysical exploration is seismic refraction survey. This method is based on propagation of wave. So based on the velocity of the wave traveling through the soils or rocks, so we'll be able to identify the type of rocks. Another method that normally performed in Malaysia is JKR or Macintosh probing. So by performing JKR and Macintosh probing, people or we will be able to determine the strength or the bearing capacity of the soil. After performing this preliminary subsurface exploration, we'll get some idea about the general information below the ground surface. So by knowing the condition below the ground surface, then we can plan and decide what type of detailed subsurface exploration method to be employed in order to perform detailed subsurface explorations. Once we have decided the method to be employed, then we can determine the number, the location, and the depth of the exploration to be performed. In addition to that, the types and number of in situ testing also can be decided. So it is important to perform this preliminary subsurface exploration before we perform the detailed subsurface exploration. Okay, these are pictures showing our laboratory staff and students performing Macintosh probing. So we took our students to a proposed project site and asked them to perform this Macintosh probing so that they could have experience to perform this probing. These are the pictures showing the equipment and the activities performed in seismic refraction survey. So the first picture here showing the seismograph, or generally we call it as data logger. This is the cable. These are the geophones to be inserted into the grounds. This is the sledgehammer used to hit the ground in order to generate wave. This picture, this photo shows the close-up of a geophone inserted into the ground. So this geophone is connected to this data logger seismograph via a cable. The function of this geophone is to detect the arrival of wave. Once this geophone detects the arrival of wave, so this geophone will send signal to the data logger to record the time of arrival of the wave. This picture shows our staff and student performing seismic refraction survey, and this picture shows the steel plate, a steel plate placed on the ground, and then this hammer here is used to hit this plate so that wave will be generated and wave will travel through the soil. So the arrival of wave will be detected by geophones, as I mentioned previously. I will explain in detail in the next video how to perform this seismic refraction survey. Okay, this slide shows the equipment used to perform resistivity survey. So this is the data logger. This is the probe to be inserted into the ground. This is the these are the connectors to connect the probe via this cable to this data logger. If you look at this photo, you can see here the probe being inserted into the ground, and this is the connector connects the probe to the data logger via this cable. This photo shows our students performing resistivity survey. Step number 5 is detailed subsurface exploration. Normally, it involves drilling of several boreholes to obtain disturbed and undisturbed sample at different depths. Okay. So I will explain what disturbed and undisturbed samples are in the next video. But keep in mind that during the drilling operation, we may obtain disturbed and undisturbed samples. So we take samples at different depths, depending upon the type of soil or depending upon the type of rocks or the condition of rocks. With regard to this detailed subsurface exploration, there's no specific formula to determine the number and depth of boreholes. Right? There's no formula, no rules. Normally, it's based on our engineering judgment. Okay? Based on our engineering judgment, normally this detailed subsurface exploration is performed at every corner and middle of the proposed structure. Those are the locations. Okay? In terms of depth here, normally they drill up to hard layer, or some people, they refer to the depth at which the stress increase due to the proposed structure is about 10% of the stress of the proposed structure. So you may refer to the topic of stresses in soil or stress increase in soil that you have learned in soil mechanics class. There are several methods that you can employ to obtain the depth at which the stress increase is about 10%. You may use a simple method, or some people call it as 2-1 method, or other methods, whichever that you are convenient with. Okay? So those are the approach. Okay? At every corner, middle of the proposed structure, and in terms of depth, you may drill up to hard layer, or maybe at depth at which the stress increase about 10% of the stress imposed by the proposed structure. If during the drilling, rock is encountered, then coring must be performed. The minimum length of the coring is 3 meters continuously. This 3 meters continuously is to ensure the rock is a bedrock, not a boulder. Okay, this picture shows the soil drilling machine. Okay, the height of the mast normally is about 25 feet. So that's all that I want to talk about as an introduction to site investigation. Until we meet again in the next videos on the topic of site investigation. Thank you.